Hello. So today's section is on laws of logarithms. And so just to recap first, we know when it comes to exponents, when we have two exponents with the same base multiply with each other, we will add the exponents. When you have two with the same base and we divide it, then we know we will subtract it. And when we have an exponent to the exponent, you will multiply them together. So right now we're going to look at the trends when you're multiplying, dividing, or having to the exponent of, or to the power of, when it comes to logarithms. So first let's look at the product law here. I'm going to scroll up here. So we're just going to let log cm equal to x and log cn equal to y. So we're just going to change these two things to the exponential form. So that means cx equals to m and cy equals to n. Okay. And now, well, we're going to look at product. Product means multiply. So we're going to multiply these two together. So if we have m times n, that is basically cx cy. And when we have the same base and we're multiplying it together, you can add the exponents. So we know mn equals to cx plus y. So if we change this back into the logarithmic form, log of the base gives us the kind of answer, and that equals to the exponent. Now remember, x from the beginning we said is basically log cm, and y is basically log cn. So right now we could fill that back in, right? And that will give us our first law. So we know log cmn basically equals to log cm plus log cn. All right, now let's look at the quotient law here. So again, we have the same relationship. I'll just write it out again. So c to the x equals to m, c to the y equals to n. This time though, since quotient means divide, we're going to divide these two things, and we'll divide m over n. And that basically is cx over cy. Same base, different exponents, we can subtract it. So it's cx minus y. Again, we're going to change this back to the logarithmic form. So log cm divided by n equals to x minus y. Similar to the the product law, x is equal to log cm, y is equal to log cn. Then we can see that, hey, when we have log base of something divided by another, we can actually split that up to have log c of the numerator subtract log c of the denominator. I think you're seeing some trends now, right? All right, moving on to the power law now. So this time we're only looking at kind of that one thing here. So we could just write this as cx equals to m. And this time we're just going to put in the letter n. So we're going to say, well, we have our exponent here, and we're just going to put it to the power of something, and we're going to do that to both sides. And again, we're just going to rewrite this back into our logarithmic form. So log base of our number equals to xn. Now remember, x is x is equal to log cm. And log cm, the whole thing is being multiplied by n. So I'm just going to rewrite this part here. I'm just going to rewrite this basically as n log cm, because I don't want to put the n at the back, because that becomes a very different meaning, right, in the log world. So I'm just going to write that down here as our third law. So log c, when we have m to the power of n, basically it could be rewritten with that exponent in the front, log cm, and that is called the power law. So these are the three laws when it comes to logarithms. So when you have log a base and two things multiplied with each other, you could split them up into one plus the other. When you have two things divided with each other, you can again split it up with one, or the numerator, minus the denominator. And when you have log base c to m to the exponent of something, you can move that exponent into the front as a coefficient, and that is called the power law. So let's put these to practice now. So we have these expressions and we want to write in individual logarithms of x, y, and z. And what I mean by individual logarithms basically means I want to have log base x by itself, log base of y by itself, and log some base and z by itself. Okay, so that's what I mean by individual logarithms. So our first one here, log 5 x times y over z. So there's different ways of going at it. I'm just going to show you one of the many ways. If you have an alternative method, feel free to go with that, as long as we kind of end up with the same result at the end, okay? So I'm just going to see, well, I see there's a division here, so I'm going to use that quotient law. So I know log 5, that numerator, subtract that denominator. So that is our first break up. And z is now by itself, but x, y is still together. And here, there's two things multiplied, so we can use that product law. So we'll have log 5x plus log 5y minus log 5z. So now that everything is all separated out, then we're done. I don't think we can simplify that anymore. Okay. Okay. Oh, and I'm just going to add these equal signs because these things are all equal to each other. Okay. All right, let's try our next example now. So very similar here. We have a numerator and denominator. So again, I'm just going to use my quotient law. So I have x to the 3 minus log y root z. Okay, and here we have y and z multiply with each other, so I'm going to just put in my equal signs, and I'm going to break down that second term even more, so minus log y plus, ooh, we have to be careful because it's subtract the whole thing, so we want to have our brackets there, log root z. And I want to have these terms by itself, and that 3 through the power law, we can move it to the front. And I'm just going to multiply out these negative signs. So we have log y minus plus, so it's going to be minus. Now, here, when we have a root, basically we could think of this as log z to the power of half. So I'm actually going to move that half to the front, and then have log z. And that is as far as we can get with this one. All right, moving on to the next example. So now we're going to use laws of logarithms to simplify and evaluate each expression. So we're actually going to get to some solution here. So in the last couple questions, we were kind of splitting things up. Now we're just going to put things together. So first, I have two logs that are being added together. So when two things are added with the same base, we can multiply it, right? So that first part could just be log 6. 8 times 9 is 72 minus log 6 to the 2. And now from here, since we have subtraction, we could basically divide it, right? 72 divided by 2. 72 divided by 2 is just log 6 to the 36. And I'm just going to rewrite this in exponential form so it becomes really clear. So log 6, 36 basically is, we know, I'm just going to write here. If we think this equals to some exponent, we don't know what that is. So 6 to the power of something equals to 36. Most of us can probably see that 6 to the 2 is 36. So therefore, that number we're looking for, that answer is 2. So this is our final solution because ultimately we're looking for that exponent. All right, so next example here, log 7 root 7. Since we have two things that are multiplied, let's break it up. So we have basically log 7 plus log 7 root 7. And root 7, remember the root basically could just mean 7 to the half, right? So we have, equal signs, log 7 plus half log 7. Now the question is, we have log 7, and twice here. So what is log 7 to the 7? Log 7. That is basically equal to, if we think of this as equal to some number, log 7 to 7 is basically equal to, I'm just going to actually erase that, equals to 1, right? Because 7 to the power of what will give you 7. So a number to the power of 1 would give itself. So we know 7 to the 7 is 1. So we could basically replace this relationship into what we've written here. So we do know log 7 is 1. And we basically have half times 1, which is just half. So it's 1.5, or 1.5, or 3/2, however you want to write that. So same relationship. So this is the solution here. All right, third example. This one is getting longer, but it's still the same idea, right? So let's just work out the brackets first. I'll leave this first log out here. And since we're adding, we could just multiply. And since we have the same base, then we can just multiply the two together. But first, we're going to move this power back so we could actually merge the two pieces together. So here we actually have log 2 to the 6 plus log 2, 27 to 1/3. And here, basically, we have 2 log 2, 12 minus log 2 to the 6 times 27 1/3. Now, I'm just going to write this on the side. Maybe I'll write it in different ink. So we know that 27 to 1/3 is basically equal to 3. So I'm going to just kind of simplify this a bit more. I'm going to move this 2 as well through the power law to the back there. So we have log 2, 12 to the 2 minus log 2, 6 times 3. I'm breaking this into many steps just for those who want to see it, but you can kind of mash a couple of steps together if you want. And this basically will continue on here. So 12 to the 2 is basically log 2, 144 minus log 2, 18. So since we're subtracting, we could use the quotient law, log 2, 144 divided by 18. And that brings you to log 2, 8. And this, if it equals to something, you will know that 2 to the power of what gives you 8? I know, I'll just write this in here. That this part here, we know the relationship is 2 to some power equals to 8, okay? All right, next part. So write each expression as a single logarithm in simplest form. State the restrictions on the variable. So first, we're just going to use the power law and move that number back into an exponent. And then we're just going to put things together using the product and quotient law and see how this will simplify. So log 4 x to the 3 minus log 4x plus log 4 x 9 over 2. Now, all is the same base, so we can actually put it together. If it wasn't the same base, then we would be done at this point. But since all is base 4, we can actually put things together. So I'm just going to start with the first term, the first 2. Since we're subtracting, we'll use the quotient law. So log 4 x to the 3 over x plus log 4 x 9 over 2. Here you can see that basically these can cancel. So that leaves us with log 4, oops, there's a 2, x to the 2 plus log 4 x 9 over 2. Since we're adding, then this is going to be a product. I'm just going to draw an arrow here. So we have log 4 x to the 2 times x to the 9 over 2. I'll put a bracket here to show that this is all within the log. Since we're multiplying 2 of the same base, we can just add those exponents, still following the same rules as exponents here. So 2 is basically same as 4 over 2. I'm going to just write this. This is basically x 4 over 2. Once we have the same denominators, we can actually add it together. 4 plus 9 is basically x 13 over 2. And if you want, you can move the power back to the front. So we have log, oops, move it back to the front. So it's 13 over 2 log 4x. Now, we haven't kind of finished solving the question yet because we need to state the restrictions. So looking at here, what are the restrictions on x? So as we can see, as we know already, x can't be a negative number, but does it have to be anything even more specific? So we know that there are no denominators in this case. So therefore, we just know that x, therefore, must just be greater than 0. Okay, so here's the last question of this section. Now, we still have the same base, and this time is looking a little different because that number that we have with the base is kind of in this big bracket. You may be very tempted to want to multiply this out, but no, you cannot do that. Okay, because basically this whole thing is that x that we've talked about when we talk about, I'm going to write on the side, when we have y equals to log cx, that whole bracket is x. So you can't just multiply it out. But we can still merge the two together through the quotient law. So that is log 8. The first one will be our numerator, and the next number is our denominator. So at this point, we'll try to just simplify this big term. And how are we going to do that? We are going to factor. So at the top, we can factor out an 8. So we have x squared minus 4. And the bottom, we're going to have to break it up into our 2 brackets, and we could factor that out into 2 and 4, minus, minus. Now, if you can see this top term here, we could actually factor it more with the difference of squares. So that'll be log 8, 8x plus 2, x minus 2 over x minus 2, x minus 4. At this point, we can see that we can just cancel out these 2 terms there. And that leaves us with log 8, 8x plus 2, x minus 4. And that's the end of it. We can't really simplify anymore. But again, we're not done our question yet. We still need to look at our restrictions. So this time, we do have denominators. And in this case, remember, denominators can't be 0. So that means our x minus 4 must be greater than 0. So if we rearrange that, then we know x must be greater than 4. That is our restriction. And that is it for this section.